Alrighty, welcome to lesson 14.5. Page 658 and 659. Ladies and gentlemen, we're going to continue with one of my favorites, and that is the Pythagorean theorem. Today, we are going to use the converse of the Pythagorean theorem, and we're going to use something called the distance formula. And the distance formula can be challenging. I'm certainly going to show you ways to make it simple. But that will be in our last lesson, or our last video. This is our last lesson. But in our last video tonight, we have 3 tonight. Be prepared. Here we go. Our essential question: in what other ways can we use the Pythagorean theorem? We've already used it. We've already used it. We've already used it by saying, hey, I have a right triangle. This triangle is definitely a right triangle. And if you use the formula a squared plus b squared equals c squared, we can find one of the missing sides. We can find a leg, or we can find the hypotenuse. So when we talk about the converse, you should have taken some notes on the converse on the top of page 658. The converse says, hey, I just have this triangle here. It's just a triangle. If this formula works, then the triangle is a right triangle. So what we're going to do now is we're going to give you all the sides, the 2 legs and the hypotenuse, and say, hey, do we have a right triangle? So let's just get right down to it. Tell whether the triangle is a right triangle. So ladies and gentlemen, that means we have to use what we know about Pythagorean's theorem in right triangles, and that is that the longest side is the hypotenuse, that is the c. So a squared plus b squared equals c squared. We know that c squared has to be 42. So we go 24 squared plus 36 squared equals 42 squared. And when we do that math, 24 squared is 576. Plus 36 squared, which is 1,296. Is that equal to 42 squared, which is 1,764. When I add these two together, I get 1,872. Is that equal to 1,764? No, no. So this is not a right triangle. It is a triangle, but it's not a right triangle. Try it again. A squared plus b squared equals c squared. Well, c has to be the longest side. So the other two, 0.5 squared plus 1.2 squared. Is that equal to 1.3 squared? And the math says that 0.5 squared is 0.25 plus 1.2 squared is 1.44, equaling 1.3 squared, which is 1.69. And then when we add these two together, we get 1.69. Is that equal to 1.69? And the answer to that is yes, they are equal. So this, in fact, check, is a right triangle. Where would that right angle be? That's right, it has to be there. If this is the longest side, it has to be opposite the right angle. So there definitely would be one there. Moving right along, do the side lengths 15, 20, and 24 form a right triangle. So we don't have a picture now. We just have these lengths. And so again, we have to look at the 3 lengths. Which one's the longest? That one would have to be the hypotenuse. So we write our formula. 15 squared plus 20 squared equals 24 squared. That's 225 plus 400, equaling 576. Adding these two together, 625 equals 576. Not today. So no. That is not a right triangle. How about this time? 34, 16, and 30. I didn't put them in order for us this time. So we got to use what we know. Longest side is the hypotenuse. So 16 squared plus 30 squared, equaling 34 squared. And when we do the math, 16 squared is 256. Plus 300 squared, that's 900. Equal 34 squared, which is 1,156. If we add these two together, we get 1,156. Is that equal to 1,156? You dang darn snippy it is. Yes, indeed. This is a fact, a right triangle. Outstanding. One more time, and I know you can do these things, but I'm just showing you a little bit difference that they're going to give you when they give you side lengths. They might give you some funky looking number. Some funky looking number like the square root of 28. Still makes no difference. You know that the square root of 28 has to be less than 28. So you recognize that 65 is the longest side, so you go, hey, the square root of 28 squared plus 63 squared. Is that equal to 65 squared? And we've already learned, you take the square, you square a number after you take its square root, it's the number on the inside. It's the radicand. Plus, well, 63 squared is 3,969. 3,969. And 65 squared is 4,225. When I add those two numbers, I only get 3,997. Is it equal to 4,225? No. N-O. This is no. It's not a right triangle. One more time. 290 square root of 96 and 10. Well, I know that the square root of 96 has to be less than 10 because I know 10 squared is 100. So here we go. 2 squared plus the square root of 96 squared equaling 10 squared. 2 squared is 4. Squaring the square root of 96 gives me 96 equals 100. And 100 does equal 100. And so yes, this is a right triangle. All right, that was pretty straightforward, ladies and gentlemen. The converse of Pythagorean's theorem. Here we go with our quick write, our first one of the night. Tell whether these side lengths, 18, 80, and 82, form a right triangle. Take a quick break, come back, video number 2 in just a few.